Good morning to all. Am I audible? Just message in the chat box. Just type a message in the chat box whether I'm audible or not. Okay, I'm going to start the session. Today I will discuss mesh analysis. If sufficient time is there, I will even discuss about the nodal analysis. Okay. Okay, let us discuss about the mesh analysis. So mesh analysis is also known as mesh current method. And this mesh current method, it is a network technique where mesh or loop currents directions are assigned. Okay, and then analysis using Kirchhoff's voltage law and Ohm's law are applied systematically to solve the unknown currents and voltages. Okay, so this method, mesh analysis, is used to um, solve or determine, okay, to solve or to determine the unknown currents and voltages by applying what? By applying Ohm's law as well as Kirchhoff's voltage law. You can call this mesh analysis as mesh current method. Okay, if you want, you can note it down. So there is a specific procedure that is to be followed for mesh analysis. First of all, we have to identify how many meshes are there in the given circuit or network, and we must assign mesh currents within each mesh, either in clockwise direction or anti-clockwise direction. After that, we have to determine, after assigning the mesh currents, we have to determine the mesh current values by applying Kirchhoff voltage law and Ohm's law. And after determining the mesh currents, if our voltages are asked, if we have to determine the voltage across each element depending on what is asked in the numerical problem, whatever terms that are being asked, we can determine those terms. Okay, so how to implement mesh analysis and how to determine the unknown currents and voltages, let us see in the numerical problems. So you can note it down in your notes. Okay, you can note it down. So this is one of the numerical problem. In this numerical problem, where is my cursor? Yeah, I will take the laser pointer. We have to find the voltage across 30 ohms resistor using mesh analysis. That's it. This is the question. So this is a given mesh, okay, or given circuit or given network. So in this given circuit, 30 ohms is here. So what did they ask? They have asked us to determine the voltage across this 30 ohms. That's it. By applying what? By applying mesh analysis method. Okay. So I will just give you a minute. You can note it down. You just copy down the question and draw the circuit. As soon as you complete, you can mention in the chat box. You just type C. Just type C in the chat box so that I will come to know that you have completed. Okay. As soon as you complete, just type C in the chat box. So at the end of this session, I will forward the Google form. You can give your feedback in that Google form. Whatever questions are asked in that Google form, you can fill those questions and submit it. If you complete, you can mention just C in the chat box. You better try to draw the circuit with free hand so that time is saved. Okay, so now to save the time, you better draw the circuit with free hand. Don't use pencil, scale and all. Okay, meanwhile, when you people are still drawing, so let me just discuss about this circuit. So if you observe here in this circuit, there are two meshes, two closed paths. This is one mesh, this is another mesh. Okay, so there are two meshes in this circuit. So since there are two meshes, we can assume two mesh currents. Okay, so let's assume in this mesh current is I1. In this mesh current is I2. Okay, and the mesh currents directions you can assume either in clockwise or anti-clockwise direction. That I will show you in the next slide. Since you people are drawing, okay, you have completed. Okay, so I will change this slide and I will show you how to consider the mesh current. So here two meshes are there, mesh 1 and mesh 2. Okay, mesh 1 and mesh 2. Two meshes are there. I will take the laser. Mesh 1 is there and mesh 2 is there. So since two meshes are there, we will consider two mesh currents. Okay, so since two meshes are there, we will consider two mesh currents. So let us assume just draw a circle in this mesh, draw another circle in the second mesh. Okay, and mention I1 in one mesh, mention I2 in another mesh. Okay, so you can consider I1 here and I2 here. It's your wish. Okay, it's not mandatory to assume I1 only in the first mesh and I2 only in the mesh 2. It's not necessary. Just first of all, identify how many meshes are there, how many closed paths are there. You can see here, this is one closed path, this is one closed path. So two meshes are there. So after identifying how many meshes are there, we must mention the mesh currents. So just draw a circle in one mesh, draw another circle in the second mesh. Now inside the first mesh, just mention some notation, some loop current. Okay, so mesh current or loop current we can say. Some write down I1 in one mesh and I2 in another mesh. After that, so whatever circles that we have drawn here in both the meshes, so those circles must be assigned with some direction, either clockwise or anti-clockwise direction. You must assign. Okay, so if you observe here, I have already assigned one direction. This is what? This is clockwise, isn't it? I have assumed clockwise. You can assume either clockwise or anti-clockwise, your wish. So here I have assumed clockwise mesh current direction. So I1 current is flowing. I am assuming that I1 current is flowing in clockwise direction in mesh 1. Okay, that's the meaning of this. Similarly, in mesh 2, is just observe. I have here also have assumed clockwise direction. Okay, you can assume both the loop currents or mesh currents in clockwise direction or both the mesh currents in anti-clockwise direction or one in clockwise, other one is anti-clockwise, your wish. Okay, so mesh currents directions are our wish. We can assume any direction that we want. So here I have assumed clockwise for both the mesh currents. So here two meshes are there. So I have, that's why since two meshes are there, I have considered two mesh currents, I1 and I2, and the direction of these mesh currents, both the mesh currents I have assumed clockwise. So whatever circuit that you have already done for the numerical problem, you just write solution, and but it's better if you redraw the circuit. And okay, so which in the earlier slide what I have shown was the circuit which was given in the question. This is the circuit that was given in the question. You better you write solution and redraw the circuit, so that uh, you will be knowing what are all the modifications that you have to do in the given circuit when mesh analysis is asked. Means when it is asked to determine some parameter using mesh analysis. So here now our mesh currents are what? I1 and I2. Okay, I hope you might have drawn, I don't know. Okay, now here we have two meshes. So let us start with mesh 1. Let us consider mesh 1. Okay, now I have already told you we have to identify the meshes. After that we have to assume the mesh currents, and after that in the procedure, okay, just orally I told you earlier, and after that we have to implement Kirchhoff's voltage law and Ohm's law to determine the unknown parameters. So first of all, they have asked us to, of course in the question they have asked us to determine the voltage across 30 ohms. Okay, but first of all let us determine the mesh currents. After later on we can determine the voltage across 30 ohms. First of all let us determine the mesh currents, that is I1 value and I2 value. So let us consider first of all mesh 1. Okay, and in this mesh 1 let us implement Kirchhoff's voltage law and let us determine I1 value. Later on we will apply Kirchhoff's voltage law in mesh 2 and we will determine I2 value. So I'm going to the next slide. So now applying Kirchhoff's voltage law in mesh 1. So I will just copy that circuit in this slide. 1 second. So it will be easy for me to explain by looking at this circuit, by showing you this circuit as well as the equation. So now here, see here, we want to implement what? We want to apply KVL in mesh 1. So this is our mesh 1. In this mesh 1, I have to apply KVL. So in this mesh, let us see what are all the parameters that are there, or what are all the elements that are there in this mesh. There is a source of 20 volts. There is a resistor of 5 ohms. And there is another resistor of 10 ohms in this mesh. Okay, you just see how many elements are there. Total 3 elements. One source is there, one 5 ohms resistor is there, one 10 ohms resistor is there. And according to Kirchhoff's voltage law, okay, according to Kirchhoff's voltage law, the algebraic sum of source voltages in a closed path should be equal to the algebraic sum of the voltage drops in the closed path. So how many voltage sources are there in this closed path? Only one voltage source, that is 20. So I have written here 20 is equal to voltage drop across this element plus voltage drop across this element. What is the voltage drop across this element? 5 ohms is there. I will take a pen. So this is the current I1 which is flowing through here, and it is flowing like this and this. Okay. So what is the current that is flowing through 5 ohms? How much current is flowing through 5 ohms? Here mesh current I have assumed I1, isn't it? Mesh current I have assumed I1. So I1 current is flowing through 5 ohms. So what is the voltage across 5 ohms? 5 into I1. So 5 into I1 is the voltage across 5 ohms. Similarly, what is the voltage across this 10 ohms? Voltage across 10 ohms. How much voltage is there across 10 ohms? If you observe, 10 ohms is in between mesh 1 and mesh 2, isn't it? 10 ohms is in between mesh 1 and mesh 2. Okay. So, on the left side of this 10 ohms, I1 current is there. On the right side of this 10 ohms, I2 current is there. Okay. On the left side of 10 ohms, I1 current is there. On the right side, I2 current is there. What is the direction of I1 current? I1 current is downwards. What is the direction of I2 current? I2 current is upward, isn't it? You just observe these arrow marks. This is downward. This is upward. Okay. Downward and upward. So one side, both directions are opposite to each other, isn't it? On one side, it is downward. On the other side, it is upward. Okay. On the left side, it is downward. The current direction is downward. On the right side, the current direction is upward. Okay. So, means both the currents I1 and I2, okay, which may flow through these 10 ohms are opposite each other. So, therefore, difference of I1 and I2 will flow through 10 ohms. Okay. So, difference of I1 and I2 will flow through 10 ohms. So, difference means I1 minus I2. Why I1 minus I2? Since we are in mesh 1, okay, that's why I1 minus I2. If we were in mesh 2, we might have written I2 minus I1. So, 10 into, okay, Ohm's law. What is it? What is according to Ohm's law? Resistance into current is equal to what? Voltage. So resistance is how much? 10. What is the current? Difference of I1 and I2. So I1 minus I2. So 20 is equal to what? Source voltage. According to KVL. 20 is equal to what? 5 into I1 plus 10 into I1 minus I2. Now expand this. Okay, now expand this equation. So what I have done is simply I have shifted all these right side terms to the left side here in the next equation. You meanwhile while I am explaining, you people can note it down in your notes. So 20 minus 5i1 minus 10 in minus 10 into I1 minus I2 is equal to 0. I have shifted right side terms to left side. After that I have expanded this 10i1 and so this minus 10i1 minus into minus plus 10 I2 it will become. So minus 10 I1 and minus 10 minus 5 I1 is nothing but minus 15 I1. Okay. So 20 minus 15 I1 plus 10 I2 equal to 0. And here. Okay. Later on, I have written this equation in terms of I2. So 10 I2 is equal to 15 I1 minus 20. Okay, this is what I have got. So if you, as soon as you complete each slide, if you are copying it down, you just mention C so that I will just check in the chat box and I will change the slide. So this is what we have got. Now if you carefully observe here on the left side and right side, all terms are multiples of 5, isn't it? They are multiples of 5. So what I have done in the next slide is I have divided the above equation with 5. Since there is no need to divide with 5 at all, but I have divided it with 5 so that I will get smaller magnitude terms. So that's it. That's the only reason. No need to divide with 5. You can take that equation as it is and you can consider it as equation number 1. Okay, you can keep it as it is and you can consider it as equation number 1. No need, but I have, see, everyone won't think in the same pattern, isn't it? So the pattern of thinking from one person to another person changes. So according to me, this is what I have done. So what I have done is, since they are multiples of 5, simply have what I have done is divided with 5, and I got 2i2 is equal to 3i1 minus 4. Later on I have multiplied with 2 so that it will be easy for me to simplify with equation number 2. So that I have already done here itself. So simply have divided by 5, and later on I have multiplied with 2. Okay, so no need to do this at all, because these sort of thoughts will not come in our mind. Everyone will not get this sort of thoughts. It's not compulsory to do this. Simply you can consider this equation as 1. Okay, at present, since you are following me, you are listening to the class, you just copy it down. But in your exam, no need to think about dividing or reducing or multiplying with any term. You can consider this equation as 1 and simply substitute these terms in the calculator, and it will give you the I1, I2 value. So I hope you all have the scientific calculator. If you are studying BTech, you must definitely have the scientific calculator. Now at present, you just copy it down, since you are at the beginning stage and you are learning. Okay, so just copy it down. Okay, I hope you have completed. Now let us go to mesh 2. Okay, so in order to go to mesh 2, once again I will copy the circuit in this slide. Now mesh 2, you see in this diagram, and this is our mesh 2. So we have to apply KVL, Kirchhoff's voltage law, in mesh 2. So when you apply in order to apply KVL, just check all the elements in this mesh 2. So what all the elements are there? There is a source, voltage source, there is 30 ohms resistor and 10 ohms resistor in this mesh 2. 3 elements are there. So apply Kirchhoff's voltage law. Algebraic sum of source voltages must be equal to the algebraic sum of the voltage drops across each elements in a closed path. So in this closed path, how many elements are there? 3 elements are there. One is the source. So 80. So 80 is equal to, so what's the current in 30 ohms? What is the current in 30 ohms? Only I2 current will flow through 30 ohms. So 30 into I2. Okay. Voltage across 30 ohms is 30 into I2 plus the 10 is there. 10 ohms is there. And as I have already explained in the previous slide, that here 30 ohms, 10 ohms is there, and 10 ohms is in between mesh 1 and mesh 2. Okay, 10 ohms is in between mesh 1 and mesh 2. So both I1 and I2 currents will flow through 10 ohms. But if you carefully observe here, what you can observe, as I have already told you, in mesh 2, the current direction that is upward. In mesh 1, the current flowing through 10 ohms will be according to mesh 1. Okay, it will, current direction I1 will be downward. Both are opposite to each other. Therefore, both I1 and I2 are opposite to each other. Therefore, I will erase that, and I will just here I1 is downward, I2 is upward. Since I1 is downward, I2 is upward, differential current will flow through 10 ohms. So since we are discussing about mesh 2, okay, since we are applying KVL in mesh 2, therefore you must write 10 into I2 minus I1. So for when we were in mesh 1, we wrote 10 into I1 minus I2 for mesh 1. Now we must, since we are in mesh 2, okay, since we are applying KVL in mesh 2, we must write 10 into I2 minus I1. Okay, after that mathematical simplification we can easily do, isn't it? So simply what I have done is I have sent all these right side terms to the left side. Okay, I have sent it to the left side. So when they are moved to the left side, it will become minus 10 into I2 minus I1 minus 30 I2. plus 80 equal to 0. This is what you will get when you transfer all the terms from right side to left side. Okay, so after that, okay, so next step I have written here, divide the above equation by 10. No need to divide by 10. Okay, I have divided it. Now if you won't get that thought, it doesn't matter. You can simply rearrange the terms and write the equations in terms of as I have written for equation, you can write it in terms of I2. Here also you can do the same. Okay, but I have divided with 10. Okay, at present, since you are following me, you just divide by 10 and write down the next equation. So if you divide by 10, what will happen here? Minus into I2 minus I1, minus 3 into I2, plus 8 equal to 0. That's what you will get. And after that, you can see here two I2 terms are there, minus I2 and minus 3 I2 is there. So it will become minus 4 I2 plus I1 plus 8 equal to 0. So send I1 and 8 to the other side. So you will get 4 I2 equal to I1 plus 8. Just copy it down. That's it. Now we have two equations, equation 1 and equation 2. So I hope you people might have written. No need to draw this circuit again and again. Simply you know to explain the equations, how to write the equations. I have copied that image in this slide also. Now let us solve equation 1 and 2. Okay, you can, if you have a scientific calculator, you can substitute these two equations in the scientific calculator. Directly you will get the values for I1 and I2. Okay, so but here I have manually solved it here in the next slide. So by solving equation 1 and 2, what I am going to get is, if you observe here, equation 4I2 is equal to something, and in equation 1, 4I2 is equal to something. So that's why I have multiplied the this above equation with 2. Okay, so okay, so no need to do this directly. You can substitute these two equation 1 and 2 in your scientific calculator, and you will get the I1 I2 values. So according to me, equation 1 and equation 2, when I equate it, I will get 6I1 minus 8 equal to I1 plus 8. And by simplifying the above equation, I will get 5I1 equal to 16. So here I1, send it this side, it will become minus I1. So 6I1 minus I1, you will get 5I1. Minus 8, send it to this side, it will become plus 8. So 8 plus 8, you will get 16. I don't think it is necessary for me to explain how to simplify a given expression. You might be already knowing that. So 5I1 equal to 16. So I1 equal to 16 by 5 amperes. So I didn't solve it. If you want, you can solve it. Okay, you can divide 16 with 5 and you can write whatever numerical value that you are going to get. Okay, so I have got some value for I1. Now you just copy it down as quickly as possible. Okay, you might have completed, I think so. So let us proceed. Now substitute I1 in your equation 2, or you can even substitute in equation 1. Okay, if you substitute it in equation 2, you will get 4I2 is equal to I1 value was 16 by 5. So plus 8. So 16 by 5 plus 8, you will get 56 by 5. I2 equal to some 14 by 5 you will get. You can divide 14 with 5 and you will get some numerical value. Okay, so just write it down. So now we have determined the mesh currents, I1 current and I2 current. Okay, so we have determined I1 current and I2 current, and in our question they have asked us to determine what? They have asked us to determine the voltage across 30 ohms resistor in the given circuit. So that we will do. I hope you have written. So voltage across 30 ohms resistor. Where is my pen? Voltage across 30 ohms resistor. What is the voltage across 30 ohms resistor? I2 into 30. Okay, so here I have written R, but I2 into 30, isn't it? Voltage across this resistor, this circuit. I will go just show you the circuit. So what is the voltage across this resistor? Voltage across this resistor is I2. Current in this resistor is how much? I2 current. So I2, my cursor won't listen to me. I will just erase it. So voltage across 30 ohms resistor is I2 into 30. Okay, I2 into 30. What is I2? Just now we have calculated. Substitute I2 value. Okay, substitute I2 value, that is 14 by 5 into 30. 5 ones are 5, 6 are. Okay, so 14 into 6, you will get 84 volts. So voltage across the 30 ohms resistor is 84 volts. So this is the way mesh analysis is implemented. Okay. To determine the voltages or currents across. Yes, so you can determine voltage across any other element. So you already know the current and voltage equations. If you complete, we will proceed further. Completed? Okay, let us go to the next problem. So if anyone wants me to repeat, you can type R. If you are unable to follow, you can type R. If you type R, I will just repeat what I have already explained. Or later on, when you are free, if you are unable to follow, later on once again listen to this lecture. I have tried my best to explain in the simplest possible way as I can. Okay, let us go to the next numerical problem. So here I have taken an AC circuit here. So in this problem, you have to find the drop across 2 ohms. What is meant by drop? What is meant by drop? Drop means nothing but voltage drop. Okay, so drop means voltage drop. They didn't mention voltage drop here, they have simply mentioned drop. Drop means always voltage across. Okay, voltage drop or voltage simply. So voltage across what? 2 ohms. Where is 2 ohms in the given circuit? This is 2 ohms. So we have to determine voltage across 2 ohms resistor in the network for the shown figure using mesh analysis. Okay, so using mesh analysis, we have to determine the voltage across 2 ohms. So here if you carefully observe, there is a voltage source, there is a current source, and there is a resistor, 2 resistors, 1 capacitor and 1 inductor is there. Okay, so this is our sinusoidal input voltage. Okay, and voltage magnitude along with the phase angle is mentioned. Also current magnitude along with its phase angle is mentioned. Even mesh currents are also mentioned. I1 current and I2 current both are in clockwise direction. So in the question itself they have given the mesh currents. Okay, so we need not worry about, there is no need to draw mesh currents on our own, and no need to decide in which direction mesh currents will be there. So in the question itself they have mentioned the mesh currents, so we need not bother about the mesh currents at all. Okay, so now, so here what we have to implement, we have to implement mesh analysis in how many meshes are there here, how many meshes are there, mesh 1 and mesh 2, two meshes are there. Okay, two meshes are there, so we have to determine mesh current in mesh 1 and mesh current in mesh 2 first of all, isn't it? That's what we have done in the previous case. So this is our mesh 1. Okay, my cursor is a very sensitive cursor. Okay, so if I press harder, immediately a straight line will come. That's why, so I will, even though it is difficult to handle, I'm trying my best. This is mesh 1, this is mesh 2. Okay, already it has gone, see. Okay, S has gone somewhere else. Okay, mesh 1 and mesh 2. So if you observe in mesh 1, what are all the elements that are in mesh 1? Elements in mesh 1. Current source, I will take the laser. Better, it's better to take the laser. There is a current source. There is a resistor of 3 ohms. There is a resistor of 2 ohms. There is a capacitor of minus J 2 ohms. Okay. So minus J 2 ohms. Another that is capacitive. See, whenever it is mentioned, okay, so it's not capacitance value. Whenever it is mentioned ohms, see here also inductor, for inductor also they have mentioned ohms here. So whenever it is mentioned ohms, that means that it is the reactance value. What is it? It is the reactance value. Means X, I will erase all inks. Okay, so X C equal to what? That is C. I couldn't write C. XC. So this is what? XL, reactance value. Okay. So you know how to calculate the reactance if capacitance value and inductance value is given. I hope you know that. Okay. So, but here you just observe the units. Always whenever capacitor and inductors are there in the given circuit, you just observe the units. Okay. So if the units for the whatever magnitude values that have been given, if the units are ohms, that means it is the reactance value. So XL value is given and XC value is given. Now in mesh 1, this is mesh 1, isn't it? Mesh 1. In mesh 1, what is the source that is available here? It is the current source. Okay. So if in the given mesh, in the given circuit, in any mesh, if there is a current source, okay, so if there is a current source, due to the presence of the current source, the loop current will be nothing but the source current. Okay, loop current is nothing but source current. So what is the loop current in mesh 1? I1. I1 is the loop current. So see here, only half circle is there, full circle is not there. But you can draw the full circle and you can mention directions, okay, of these loop currents. I can't help with my cursor, it is always irritating me. So this is it. Yeah. These mesh currents are in clockwise direction. So what is I1 value? Since there in the mesh 1, the loop current is I1. There is the source in this mesh 1 is current source. This is current source, isn't it? This is our current source. Therefore, what is I1? I1 is nothing but current source value. So whatever current source value is, that is our I1. So I1 is 2 at an angle of 30 degree amperes is our I1 value. So no need to determine the mesh current I1. Why? Because it is nothing but the source current value. So now only thing left over is we have to determine I2. Okay, only thing that is left over is to determine the I2 value. Okay, now we have to implement what? We have to implement Kirchhoff's voltage law in loop 2, that is mesh 2. Okay, to determine I2 value. I1 is known. What is I1 now? I1 is nothing but 2 at an angle of 30 amperes. So write the solution, and I did not write here. I will write it. I did not write here, and okay, I will try. I'll just write it here. Okay, you can write it down. In the solution, you can mention I1 is equal to 2 at an angle of 30 degrees. Okay, that is our source current. Okay, so I'll better copy that circuit here also, here itself. Okay, I hope you people are writing. Now let us apply Kirchhoff's voltage law in this mesh 2. Okay, so better I will just make small modification. Because I was telling you that mesh 2, mesh 2. Again and again I was using the term mesh 2, and if I won't write mesh 2, it will be confusing for you. So now applying KVL in mesh 2. Okay, so in mesh 2, what are all the elements are there? You just see in mesh 2 there is a voltage source. Okay, and there is an inductor whose reactance value, see, units are ohms here, therefore it is the reactance value. Okay, next this is resistance, there is capacitance. So now if we observe, this resistor and capacitor both are in the in between mesh 1 and mesh 2. Okay, both are in between mesh 1 and mesh 2. Therefore, so I will write the mesh 1 and mesh 2 also here, so that it will be better. I will write here. I will write mesh 1 and mesh 2 so that it will be easy to understand. Okay. Now 2 ohms and resistor and capacitor both are in between mesh 1 and mesh 2. Therefore, the current, I will take this pen. So the current, if you observe, current I1 is downwards, isn't it? You just draw like this circle. Here also you just draw the circle, mention the arrow mark. So what about the current I2? It is upward. Current I2 is upward, I1 is downward. Okay, I1 is downward and I2 is upward. Besides to resistor and capacitor on the on left side and right side. Okay, on left side it is downward, on right side it is upward. Okay, because both currents are flowing in which direction? In clockwise direction. So differential current will flow through 2 ohms resistor and capacitor. Okay, differential current will flow through 2 ohms resistor and capacitor. Remember, I1 current is how much is the I1 current? That is, I1 current is 2 at an angle of 30 degree. Okay, so we already know the I1 current. Okay, now, so let us start with the elements. We can start with the elements, or in order to apply Kirchhoff's voltage law in mesh 2, we can start with the elements or we can start with the source itself. So let me start with the source. Remember that differential current will flow through the middle branch elements. Okay. Now you just see current direction is downward on the source side. It is downward, isn't it? This side it is downward. This side I2 is upward. Okay. This side it is upward. Okay. This side upward. This side it is downward. And of course they have mentioned plus sinusoidal symbol here. But if you observe this plus symbol, it is according to this plus, what does it mean? Current from this source will flow like this. Okay, current from this source will flow in the upward direction, isn't it? Current will come out from this terminal because here it is mentioned plus. And what about the loop current that we have assumed? The loop current is in downward direction. This current coming out of the source in upward direction. Both are in opposite direction, isn't it? Both are in opposite direction. Therefore, the algebraic sum of voltages, source voltages. How many sources are there in this loop? In mesh 2? Only one source is there. So the algebraic sum, only one source is there. The source value is how much? 8 at an angle of 45 degrees. Okay, 8 at an angle of 45 degrees. But we have mentioned minus here. Why did we mention minus? Because its direction is opposite to the direction that we have assumed here. We didn't assume, of course it is given in the question itself. So both the directions, current direction and the current coming out of the current that is about to come out of the source and the loop current direction, both are in opposite direction. That's why we have assumed minus here. For 1 second, I will go back to the previous numerical problem. I want to explain. In the previous numerical problem, you just observe here in this circuit, you just observe the direction, source positive is here. This is DC, isn't it? Positive terminal is here. The current will come out in this direction. The I1 current, both current directions are in same, isn't it? Both are in same direction. That's why we have written here plus 20. Okay. Similarly, just observe here. The positive terminal is downward. The current will come out in this direction. I2 current direction is also downward. Both the current directions are same. Okay. So when the loop current direction and the current coming out of the source, both are in same direction. Okay. So you must consider the magnitude of the what? Magnitude of the voltages as positive. Okay, see here 80 I have assumed positive, I have written positive, not assumed, and 20 also I have written plus 20. Okay, so why? Because both the directions are in the same direction. Whereas in this numerical problem which we are discussing, current coming out of this source is opposite to the loop current. Okay, both are in opposite direction. Therefore, minus 8 at an angle of 45 you must write. So algebraic sum of source voltages we have written. So there is no need to write there is no need to go for algebraic sum. Why? Because only one source is there. That's it, minus 8 at an angle of 45 degrees. Now what are all the elements that are available here? Inductive reactance is there, that is J1 ohm. Okay, J1 ohm reactance value. So this reactance into I2 current. Current through this 1 ohm is what? Okay, yeah, inductive reactance. Sorry, the current through the inductor is how much? I2 current. So J1 into I2. Simply reactance into current, resistance into current is nothing but voltage. Similarly, reactance into current is also voltage. So, okay, so multiply reactance value with I2 current. Okay, now this is over. This is also over. What is left over? These two are left over. Okay, so now let us write down the equations for these two. Okay, so J1 I2 we have written plus, okay, plus here here I have written in terms of I1 and I2. I should not have written like that. Okay, okay, so I will write one more equation here, J1 into I2. I can't write. I will just minimize this screen, and I have skipped one step here. I will take the text and I will write the equation here itself. So J1 into J1 into I2, this J is small letter actually, plus I can write 2, resistance value is 2, minus J2, small j, okay, resistance and capacitance value, okay, into, okay, into, now we are considering mesh 2, isn't it? So I2 minus I1. So see here, so J, I will take the laser, J1 into I2, J1 into I2 plus the whole impedance value. I have considered impedance. Okay, resistance and capacitance, capacitive reactance. I have written the impedance 2 minus J2. Okay, 2 minus J2 into, we are writing KVL in mesh 2, so I2 minus I1, I2 minus I1. Okay, so you just expand this. What do you get? 2 minus J2 into I2 minus 2 minus J2 into I1. Okay, 2 minus J2 into I1. What is I1 value? 2 at an angle of 30, isn't it? I1 is what? I1 is 2 at an angle of 30. That's what this is. Okay, so one step is missing here that I have written now. So I hope you people are able to follow. If anyone is unable to follow, if you want me to repeat, you just mention in the chat box. You just mention in the chat box if you want me to repeat. Okay, so if you want me to repeat, you can mention in the chat box. So this is it. This is what you will get after simply I have expanded this term. You will get this. Okay, later on I have just simplified this equation and I have taken I2 common, and I have written this expression, above expression, in terms of I2, that you people can write it. So I2 is equal to what? 2 at an angle of 30 into 2 minus j2 minus 8 at an angle of 45, 2 minus j1. So now you in your calculator, if you have scientific calculator, if you see here, magnitude, angle, real term, imaginary term, magnitude, angle, real term, imaginary term, you can convert all these terms into polar form or rectangular form. Okay, so how to convert polar form and rectangular form? You can search in the Google, or if you meet me, I will tell you. You bring the scientific calculator to me, and I will tell you how to convert polar terms into rectangular terms. If you know that, there is an option in your scientific calculator, POL, somewhere with maybe in yellow color or red color. It is written in your calculator, POL and REC, somewhere it is written. You can convert that. It's very simple and easy to convert rectangular to polar and polar to rectangular. So if you have polar terms, this is polar term, this is rectangular term, polar term, rectangular term. So if you have the combination of polar and rectangular, you can convert them into one form, either polar form or in rectangular form. So here I might have converted. Okay, I have converted all the terms in polar. I have done the simplification. Later on, at last, I have got this expression for I2. Okay, if you don't know how to do that, you can either meet me or in the Google itself, you just ask how to convert polar to rectangular using a scientific calculator. You will get the answer. Okay, so this is our I2. So now we know I1, we know I2. We have to determine what? Voltage across 2 ohms. This is the voltage across 2 ohms. So what is voltage across 2 ohms? 2 into I1 minus I2, isn't it? Voltage across 2 ohms is 2 into I1 minus I2. So I know I1 value, I know I2 value. Substitute I1 and I2 value. What is happening? Because it's not listening to me. Okay. So yeah. So voltage across 2 ohms is 2 into I1 minus I2. I1 is on 2 at an angle of 30 degree. I2 is 3.18 at an angle of minus 65 degree. So see here, this is polar form. This is also polar form. Okay. So I have converted this polar into rectangular form. I have written in rectangular form. After converting into rectangular, I have multiplied 2 with this, and I have got this in rectangular form. Again, I converted that into polar form. So you need a scientific calculator to convert rectangular to polar, polar to rectangular. Okay, so you can meet me to know how to convert polar to rectangular and rectangular to polar. So here simple mathematical simplification is there. So if you know how to do it, it's okay. If you don't know, later or you just go through the Google, or you meet me, I will tell you. Just write it down. If you complete, just mention in the chat box so that I will proceed to the next numerical problem. Did you complete? Okay, so I hope you have completed. Let's go to the next numerical problem. 1 second. Okay, so let us go to the next numerical problem. So we have seen a numerical problem using DC source. We have seen a numerical problem using AC source. Now let us see a numerical problem. Okay, so on using dependent sources. Okay, so here we have to determine the values of I1 and I2 in the given figure using mesh analysis. So here this is our given circuit. They have already given. What did they give? They have given the mesh currents I1 and I2. So in the given numerical problem, if even if they mention loop currents or mesh currents, okay, so you people once again complete those mesh currents. They won't give us complete. You see, half circles are there. Okay, you complete. You make it into a closed path, closed loop. Okay, so as I have done here, I couldn't draw a perfect circle. You can draw a perfect circle. Just copy it down. As soon as you complete, you just inform me. So I hope you might have completed. Okay. So just to copy this diagram in the next slide. Okay, so here applying KVL in mesh 1, you can write instead of writing this, you can applying KVL. Okay. Here I have written mesh 1 and mesh 2, left loop, right loop, that's what I have written. Instead of writing that, you can write applying KVL in mesh 1. Okay, applying KVL in mesh 1. So here, how many meshes are there? 2 meshes are there. So you just observe in mesh 1. What are all the elements that are there in mesh 1? Voltage source. This they didn't mention whether it is a resistor, inductor or capacitor. Simply they have mentioned some 6 at an angle of 0 degrees. So if nothing is mentioned, we will assume it as a resistance. Okay, that's it. And another element is there. This is J minus J 3 ohms. So it is some reactance value. Okay. So this is reactance value. Here since J is there, it is some reactance, capacitive or inductive, they didn't mention, so we don't know. So this is some reactance value. Okay. and this is since they didn't mention anything, J is not there means let us assume it has resistance, and this is our voltage. Okay. Okay, so now let us write down the equations. So here I have assumed, see, the current direction clockwise. This direction is same, isn't it? Both directions are same. So plus 9 at an angle of 0 degrees. Okay. So algebraic sum of source voltages in mesh 1. This is mesh 1, isn't it? Mesh 1. Mesh 2. In mesh 1, source voltage is 9 at an angle of 0 degrees. That is equal to voltage drop across this element and this element. Voltage drop across this element and this element. Source voltage is 9 at an angle of 0 degree, that I have written here. So you can write either in left side or right side. Okay. This I have already long back I have written, so don't worry about it. So as since I have written right side, I have left it because if I want to modify, it will take some time for me to modify all these things. So 9 at an angle of 0 is equal to what? 6 at an angle of 0 into what is the current? Okay, what is the current here? Okay, so you can even consider this as not only resistance, you can even consider it as impedance also. What is it? Whatever it may be, impedance or resistance or reactance, you have to multiply with current to determine the voltage drop. So current through the 6 at an angle of 0 degrees is I1. So 6 at an angle of 0 degrees into I1. Okay, so here we have usually we will write plus, but here they have mentioned, here they are already given minus. So minus J3 into I1 minus I2. Okay, minus J3 into I1 minus I2. I hope you have understood. If you have not understood, you can just mention in the chat box so that I will repeat. If you have not understood, you just mention in the chat box. So source voltage is 9 at an angle of 0 degrees. That is equal to 6 at an angle of 0 degrees into I1 minus, why we have written minus, usually we will write plus. Why? Because here they have given reactance value as minus. So minus J3 into I1 minus I2. Why I1 minus I2? Why? Because we are writing KVL for mesh 1. Okay. So this is our equation 1. We didn't simplify it. We have considered it as it is. We have written it as it is. We didn't do any modifications. Now let us apply mesh analysis. Mesh analysis in mesh 2. Okay. Now let us apply mesh analysis in mesh 2 or KVL in mesh 2. Okay. So no need to write this. You just write apply KVL in mesh 2. Mesh 2. I am unable to write mesh. You write it. Okay. Again 2. Okay, that's it. Okay, you can write apply KVL in mesh 2. Now where is our circuit? It is there. Just see. So here, what are all the elements? I will just take the laser 1 second. So what are all the elements in mesh 2? This reactive element is there. There is a dependent source. There is I can say impedance or resistance. Okay, so that is 3 at an angle of 0 degrees is the impedance or resistance. So one dependent source is there. So you see here, this is a voltage source. Okay, what is the magnitude of this voltage source? 2 Vx. So what is Vx value? Vx value is the voltage across minus J3 ohms. So whatever voltage is there across minus J3 ohms, that voltage into 2 will give us the voltage of this dependent source. Okay, voltage of the dependent source is what? 2 into Vx value. So this the magnitude of this dependent source voltage is depending on the voltage across this element minus J3 ohms. Okay, so now apply Kirchhoff's voltage law in this mesh 2. Okay, and right. So what I have done is this minus what is it? This reactance value, whatever they have given, since there is a dependent source whose magnitude is 2 Vx, instead of writing minus J3 into I2 minus I1, actually voltage across this element is what? Now we are applying KVL in mesh 2, therefore minus J3 into I2 minus I1 I should write, but I didn't write that because there is a dependent source whose magnitude is 2 Vx and voltage across this element is Vx. So I have written minus Vx minus, okay, minus Vx minus minus 2 Vx. Okay, see current in both, see minus plus means in both the elements current direction is same. So both are, if I take this Vx as positive, I should consider 2 Vx also as positive. Okay, so I have considered both as minus. So minus Vx minus 2 Vx. See in these two, see you just observe this loop current. Current I2 is in clockwise direction. So current is flowing downward in this element, current is flowing upward in this element, current is flowing in the same direction, in which direction, whatever direction current is flowing in this element. So therefore these two elements current directions are same, this element current direction is different. So if I consider these two as positive, this should be negative. If I consider these two as negative, this should be positive. So minus Vx minus 2 Vx plus 3 at an angle of 0 into what is the current through this? The 3 at an angle of 0 degree only I2 current. Okay, so 3 at an angle of 0 degree into I2 is equal to 0. Okay, that is of course there is a source, but there is no independent source. It's a dependent source, isn't it? There is no independent source. Dependent source is there. So minus Vx minus 2Vx plus 3j 3 at an angle of 0 degree I2 equal to 0. This is what you will get from this mesh 2. Okay, now minus Vx and minus 2Vx is there. So what do you get from this? Minus 3Vx plus 3 at an angle of 0. So whenever if the phase angle is mentioned 0, you can neglect it. 0 degree is nothing, isn't it? Even if 0 does not exist at all. Therefore, you can neglect it. I have neglected 0 degree. I have written only 3I2. Okay, so minus 3Vx plus 3I2 equal to 0. Okay, now here in both the terms 3 is the coefficient, so just take it common and send it to the right side. It will become 0. So minus Vx plus I2 equal to 0. So from this, so consider this as equation number 2. Okay, consider minus Vx plus I2 equal to 0 as equation number 2. So one more thing which we didn't consider earlier. What is Vx? Vx is nothing but voltage across minus J3. So what is the voltage across minus J3 actually? When we apply KVL earlier for previous problems, we used to write minus J3 into I2 minus I1, isn't it? If it is for mesh 2. If it is for mesh 1, minus J3 into I1 minus I2. So you can write the expression for Vx minus J3 into I1 minus I2 or I2 minus I1. I have written here I1 minus I2. If I have written I1 minus I2, what does it mean? It means that I have considered the voltage Vx for mesh 1. Okay, not for mesh 2. You can consider either mesh 1 or mesh 2. So whatever you will consider, you may get negative value. Magnitude will not change. 5 minus 2 is 3. 2 minus 5 is minus 3. Isn't it? 5 minus 2 is 3. 2 minus 5 is minus 3. Magnitude is 3 itself. Only sign has changed. So even if you write I2 minus I1 or I1 minus I2, it doesn't matter. So Vx is nothing but voltage across minus J3. Okay. So that equation I have written here and I have considered it as equation number 3. Now you can substitute 3 in 2. So I hope you might have already written this whatever is there on this slide. Now just substitute 3 in 2. Okay, substituting 3 in 2. You can write here I am using, you can write substitute 3 in 2. So if you substitute, what will happen? You will get J3. Okay, you will get J3 I1 minus I2 plus I2 equal to 0. Now you just expand this, you will get J3 I1 and minus J3 I2 and I2 is there. So here I have taken I2 common, so I have skipped one step. I might have written one step, I have skipped it. I have taken I2 common here. So if you want, you can write if you have any confusion. I will just write one expression here itself. So I have skipped this equation, I have simply expanded it, and after that you can see here J3 I1 and here it is minus J3 I2 plus I2. You can take I2 common, you will get 1 minus J3 into I2 equal to 0. Okay. Now already equation 1 we didn't simplify it, we just kept it as it is equation 1, that is our from this I will just remove this figure. And this is our equation 1, we didn't simplify it, isn't it? We didn't even expand it. So I have simply expanded and simplified it. I have written here it as, after simplification, I have written it as equation number 5. Okay, you can simplify it later on. Okay, you will get this. After simplification, simply whatever multiplications that you have to do, plus or minus, if any term is adding up, you just add it, or if any term is subtracting, you just subtract it. You will get equation number 5. Now, consider equation 4 and 5. Okay, equation 4 and equation 5, and you can write the equation 4 and equation 5 in matrix form. You can see here variables are I1, I2, I1, I2. Write down I1, I2 coefficients separately. So J3, this is J3, minus 1 minus J3, 2 minus J. Okay, so their coefficients are I1 and I2. So on the right side equal to what? 0 and 3. 0, 3. Okay, and you just determine the I1 value. You might be knowing how to determine the I1 value. Okay, so I have determined the I1 value, and in the same pattern I have determined the I2 also. So just write it down. So mathematical simplification, which you might be already knowing, just write it down. And I'm thinking to, let us see, possible, I will conclude now and I will take another session for nodal analysis after 2 p.m. today. I will conclude mesh analysis now. You just copy it down. If you complete, I will change this slide. So in the question, what did they ask? They have simply asked us to determine I1 and I2. They didn't ask us to determine any voltage across any element, isn't it? If they might have asked, we might have determined. If they might have asked us to determine Vx, see, after determining I1 and I2, what is Vx equation? Equation number 3, you can observe in your notes. Equation number 3 is Vx is equal to minus J3 into I1 minus I2. So after determining I1 value and I2 value, substitute in that equation number 3, you will get Vx value. So since they did not ask, we didn't solve for it. Did you complete? I will change this slide. If you complete, I will change this slide. Just copy it down. Simple mathematical simplification. Nothing is there for me to explain it to you. Just look at the equations. You will get the idea how to solve it. That's it. Okay. Similar in the similar pattern of I1, I have solved the I2. Here equal to is missing. This is I1. So I will take another session today itself at 2 p.m. After 2 p.m. Mostly maybe I will start at 2 or 2:15. So maybe exactly at 2, I don't know. I will discuss nodal analysis. Actually today's title was mesh and nodal analysis. But if I start nodal analysis, it will take more than an hour. It's better if people have your lunch and just take some rest after having lunch. And I will start another session after 2 p.m. We will discuss nodal analysis at 2 p.m. If you complete, inform so that I will create a Google form and will give you the link so that you people can fill the Google form. Completed? Okay then. So I will just create the Google form and I will give it to you. If you have any issue with the Google form, you just mention. Just mention in the chat box. If it is not opening, just mention in the chat box so that I will create another one. If you complete filling the Google form, just mention in the chat box. After filling the Google form, you just mention in the chat box that you have filled it. And after filling the Google form, after just mentioning in the chat box that you have filled it, you can leave the session and try to join this session today afternoon at 2 p.m. I will discuss nodal analysis in the afternoon session. So just now I saw, so there were two responses were there. So I think you people, so you can quit the session after filling the Google form. You just mention in the chat box that you have filled it and quit the session. You just return back at 2 p.m. for nodal analysis. I will edit the title also later on. After filling the Google form, just mention in the chat box that you have completed or you have filled it. Just to mention, okay, yeah, you have filled it and you can quit the session. After filling, you can leave the session. You can rejoin during the afternoon session. So I'm going to end this session within 2 minutes. I hope whoever have attended this session have filled the Google form. Okay, I'm going to conclude now. Still some of you are filling, that's why I'm waiting. Okay then, we will meet in the offline session.